Hi guys, welcome to the second video lesson in algebra and factors. Recall in our last lesson we talked about algebraic terms, expressing algebraic terms as product of factors, division of algebraic terms, and we also talked about LCM of algebraic terms. So if you missed the last lesson, you should see the last lesson before you go on with this lesson. Today we'll be looking also in HCF, which is the highest common factors. Alright, so HCF here refers to the highest factor or the greatest factor that two or more numbers have in common. Alright, so a quick example would be find the HCF of 28 and 42. Now, one of the ways to do this is, first of all, to list out all the factors of 28 and then list out the factors of 42. First, let's start with 28. Now, 28 has the following factors: 1, 2, 4, 7, 14, and 28 itself. Alright, so 42 has the following factors: 1, 2, 3, 6, 7, 14, 21, and 42. Alright, so having listed out all the factors of 28 and 42, what are the numbers that these factors have in common? Now, we discovered that in 28 we have 1, also in 42 we have 1. In 28 we have 2, also in 42 we have 2. In 28 we have 7, also in 42 we have 7. In 28 we have 14, also in 42 we have 14. So they have 1, 2, 7, and 14. And the highest of them is 14. What that means is our HCF is 14. Now, the traditional way we know how to do this is to use our division method. We place 28 side by side with 42. Then we divide. Alright, so if we look at 28 and 42, the least common factor that can divide both of them would be 2. So beginning with 2, we use 2 to divide 28 and we have 14. The same 2 to divide 42 and we have 21. Then we look for the next factor that is common to both of them. That would be 7. 7 would divide 14, we have 2, and 7 will divide 21 and we have 3. So therefore, the HCF of 28 and 42 would be 2 multiplied by 7. That will give us 14. Now, same as what we got in the first step we took. Alright, so we must bear these differences in mind. In LCM, we're looking for the lowest common multiple. So we're dealing with the multiples of those numbers. While in the case of the HCF, we're looking for the highest common factor. Now, which means before you divide that number by any of the factor, that factor must be common to both numbers. For instance, like we just did with 28 and 42, we used 2 because 2 is a common factor to 28 and 42. And then we went on to use 7 because 7 is a common factor to 14 and 21. Alright, so we can apply the same steps when we come to algebraic terms. Say when we're expected to find the HCF of algebraic terms, we can simply apply the same method that we have used in finding the HCF of numbers to find the HCF of algebraic terms. For example, find the HCF of the following: 1, AX and AY, 2, 4PQ and 4PR, 3, 10M square and 15M square, 4, 21AD and 14BD. Alright, so we're going to adopt the steps we used in the previous example. In number 1, we have AX. We place AX side by side with AY. So we divide. Now, so what is common that we can use to divide AX and AY? A. We have A here and we have A on the other side. So A will divide AX and AY. A divide AX, we're left with X. A divide AY, we're left with Y. What that means is the HCF, therefore, of AX and AY will be A. Alright, so in number 2, we have 4PQ, place it alongside 4PR. Now, 2 will go into 4PQ, and we're left with 2PQ. 2 will go into 4PR, and we're left with 2PR. Using 2 again, 2 will go into 2PQ, we're left with PQ. 2 will go into 2PR, we're left with PR. Now, what is common to PQ and PR? Letter P. So we use the P to divide both of them. P will go into PQ, and we're left with Q. P will go into PR, and we're left with R. A HCF of 4PQ and 4PR will be equal to 2 multiplied by 2 multiplied by P. That will give us 4P. Then in number 3, we have 10m square and 15m square. Now, the least number that can divide both of them would be 5. 5 will go into 10, we're left with 2m square. 5 will go into 15, and we're left with 3m square. M is common to both of them. There's nothing common that can go into 2 and go into 3. But m is common to both of them, so we use m to divide both of them. M will go into m square, we're left with 2m. M will go into m square on the other side, we're left with 3m. M is still common to both of them again, so we use m to divide again. M will go into 2m, we're left with 2. M will go into 3m, we're left with 3. So therefore, the HCF of 10m square and 15m square would be equal to 5 times m times m. That will leave us with 5m square. Alright, so in number 4, we have 21AD and 14BD. What is common that can go into 21 and 14? That will be 7. 7 will go into 21, and we're left with 3AD. 7 will go into 14BD, and we're left with 2BD. Now, what is common to both 3AD and 2BD? That would be D. So we use D to divide both of them. D will go into 3AD, and we're left with 3A. D will go into 2BD, and we're left with 2B. Therefore, the HCF of 21AD and 14BD is equal to 7 times D, which is 7D. Alright, so if you have any questions, send it through our usual channels. Here's a quick exercise for you to do. Find the HCF of the following. 1. 2xy and 7xz. 2. 9pq and 11pq. 3. mn square and m square n. 4. 8de and 6de. 5. 18z square y and 27x square y square. Alright, so please ensure you do the exercise and solve beyond the exercise that you have been given. See you in the next lesson. Thank you.